All right, James, here's another batch of problems for you. Problem 15, it's a statistics problem, and it is, and statistics, I talked to you about statistics a little bit. You know, don't ever select an extreme answer, like something's the best or something will never happen, because that's not what statistics does, and you have to stay within the group that you've studied. So you can't do a study with a particular group and then expand the results to include people that weren't in the original, not the group itself, but the population of the group that you studied. So in other words, if you studied 17 to 20-year-olds, you can't jump out of that group and talk about 22-year-olds. So like your answer choice on 15 said, treatment X improves eyesight better than all other available treatments. And that's just not stated in the paragraph stating the conditions. So the correct answer there is much milder. Treatment X is likely to improve the eyesight of people who have poor eyesight. So the group that was studied had poor eyesight, and all it says is it's likely. It doesn't guarantee that it'll improve it, it's likely to improve it. So that's answer choice A. Problem 16, you're being asked where is the Y value for F and the Y value for G, where do they cancel out to equal 0? Well, you can see out over here that this graph is not the mirror image of this graph. So my Y values here are never going to cancel with my Y values there. The interesting thing about the way the two graphs interact is right in here. And in fact, right there, my Y value is 2, and there my Y value is -2. And I didn't fully grid that thing in, but I guess I can do it now. Where does that happen? At x equals -2. So at x equals -2, one of my Y values is +2, and the other one is -2, and that makes the two Y values cancel out. Let's go to 17, and I think it's 17. Yeah. So, yeah, it's interesting you got 17 wrong, but you got 18 right. But let's talk about, the question is, how is the quantity of the product supplied? This is the supply curve, or, line indicating supply, and this is the demand. This is sort of a valid economics depiction. The supply goes up as the price goes up, more people are willing to produce it, and the demand goes down as the price goes up because less people want to buy it. So things have a tendency to work toward that. In an ideal world, things work toward that equilibrium point where the supply equals the demand, but that's kind of a blah. Here, we want to think about the slope of the supply curve, the supply line, and the slope is how S changes compared to how P changes, and that's equal to 1/2. And that means for every $2 the price goes up, the supply will go up by 1. And the question is, how much is the supply going to go up if the price of the product is increased by 10? And it's going to go up by half that amount, so the change in the supply equals, +5. That's because the slope is 1/2, or in this case, 5/10, you could say. All right, I'm going to go on to problem 22, which is a system of equations. It's kind of an unusual one. They're telling us that x plus two other numbers, and we'll call those y and z, add up to 800, oops, I'm not on the right page, and 55. One of the tricks in this problem is then it says that x is 50% more than the sum of the other two numbers, which we're calling y and z. So x is 50% more. How am I going to write that? I'm going to call that 1.5, because it's equal to y and z plus 50% more of y and z. So that is 1.5 of y and z. And see, this is a system of equations, but it's a weird one kind of, because I've got 3 unknowns and 2 equations. Normally I wouldn't be able to solve for it, but in this case I'm going to go ahead. You can use your calculator and just, we want to get y plus z by itself, so divide by 1.5. I'm going to do it by calling 1.5 3 over 2. You could divide by 1.5 as well, and then but this way I'm going to multiply by 2/3. I'm going to get 2/3 x equals y plus z. And see, the reason we did that was so that now I've got y plus z here, and I had y plus z up there. If I replace y plus z with 2/3 of x, I get an equation that just has x in it. And I get this. That's going to be 5/3. That's going to be 5/3 of x equals 855. And if I would multiply both sides by 3/5, but whatever, you're going to get x equals 513. Yeah. So hopefully that's clear. We knew that those 3 numbers added up to 855. When they said that x is 50% more than y and z, we were able to write that out like this. I turned that into a fraction. You could have just said it's x plus 1 plus x divided by 1.5 and see what that's equal to, or but I multiplied both sides by 2/3 to get rid of that 3/2, and then I had an answer for y plus z, which I substituted in up there to have an equation just with x in it, which was this, and then we just had a little bit more to do to get to that answer. All right, James, I'm going to send you this one, and then I'll keep doing more. Okay, bye.